Viewers and dear students, hello viewers, assalamu alaikum. I hope all of you will be good and happy mood. Today we are proceeding the next MCQs. Before this is the last episode of integration. So this is the last video I am doing today. So question number 115, integration of 0 to up to 3 dx divided by x square plus 9. As we know that according to the formula, dx divided by a square plus x square is, we know that 1 over a tangent inverse x by a plus c. This is the general formula. If we are applying limits, so C is here finished, ignored. Now according to this rule, if we are changing here, first of all we write the given question 0 to 3 dx, and we write here 3 square plus x square. So this result will here a is equal to 3, 1 by 3 tangent inverse x divided by a, x divided by 3, and limit as 0 and 3. Now we are applying limit, integration of tangent inverse. First we put upper limit 3 divided by 3, in the place of x we put 3, and similarly tangent inverse, in the place of x put we 0. This is the lower limit according to the formula of f of b minus f of a. Mean first of all we put upper limit, then put lower limit. 1 by 3 tangent inverse, so this will be equal to 1. Both are cancelled to each other, we get 1 minus tangent inverse, and this will be get 0. Now as we know that according to the tangent inverse formula, or we can use the calculator, so result will be pi by 4 minus tangent inverse is equal to 0. So if we are multiplying pi by 12, here the correct option D is the correct option. And f of x dx is equal to lambda x plus c. So then f of x is called, is called integrand, because we are finding here is derivative, so this function will be called integrand. So the correct answer is integrand. Question number 117, if y is equal to f of x, then differentiable of y is. Actually y, given that dy is equal to f of x, if we are differentiable, we are differentiate with respect to x, so we can write dy by dx is equal to dy by dx fx. So this will be equal to dy by dx is equal to f dash x, we can write. Now dx we change here, so dy is equal to f dash x dx. Now this is called y is differentiable. The correct option here C is the correct option. 18. Who has given the idea to find the area under the curve by use of integration? Use of integration we have already discussed in the first video, in the first lecture. Integration I have already defined. So there are two mathematicians, one is Newton and the other is Leibniz, who has discovered, who has worked on integration, but the idea about the area under the curve was given by Archimedes. So here Archimedes is the name of scientist. He has given the idea to find the area under the curve by use of integration. So question number 119, inverse of integration. As we know that inverse of integration, here dx is given and we put on our d. So dy by dx is required. Dy by dx, here dy by dx is required because both of integration dx is here function is required. If both are cancelled, so 1 over d and dx, so both will be cancelled, we get here x plus c. So it means that here derivative with respect to x is required because here we are finding integration with respect to x. So dy by dx is the answer. 20, integration e power x into cotangent x minus cosecant square x dx. So here we are using the product rule. Product rule of, you check the answer, here is minus given. If we are applying here, so here will be get positive, and here a cosecant square that is already given, so we cannot use here. And here we take the cosecant x, cotangent x, so that is also not suitable. So this answer, if we are finding the derivative of the d part, so we check here dy by dx, so e power x cotangent x, cotangent x plus c. If we find the derivative of this function, here we use the product rule. First of all, I am taking the derivative of ex, cotangent x, derivative of ex plus. So because we are using product rule here, and ex derivative of cotangent x, and derivative of constant is 0 because we are differentiating with respect to x, so there is no x, so the result will be 0 here. So cotangent x and ex plus derivative ex cotangent x minus cosecant square x, minus cosecant square x plus this will be 0. So ex, if you take common, here we get cotangent x minus plus into minus minus cosecant square x. So the answer, if we check, this answer is available in the function integration. Here this is available, so option D is the correct option. Question number 121, integration sin x minus cos x over sin x plus cos x dx. Here we are using substitution method. So let first of all we write the, in the denominator term, supposition put t as equal to sin x plus cos x. If we are differentiate with respect to x, so we can write dy by dx is equal to sin x derivative cos x and cos x derivative minus sin x. But look here, in the actual, in the question we are required sin x plus minus cos x. If we take here common minus common, so we get in the denominator term plus, and here minus cos x, because minus into minus plus, so here is plus dy by dx. So we can write dt is equal to minus sin x minus cos x dx. Dx is multiply here, and this minus sign is not required. We are dividing both sides by -1. We get here minus sin x and minus cos x dx. Now this result we substitute in the above equation here. So look here, this result is available. So it is result is minus dt, and replace of minus integration minus dt, and we put already sin x plus cos x is equal to t. So we get here minus log of t plus c. We put the result of minus t is equal to sin x plus cos x plus c. Now we check the option minus plus minus b is the correct option. To sin x plus cos x, if we are finding his derivative. So we get here cos x minus sin x. We take here minus common, minus sin x minus cos x, and if we are putting here this result, so here integration f sin x plus cos x we are required here, this one result is given. So this will be f dash minus f dash x plus, and here f of x dx. So in this situation we are finding the formula log of f of x plus c. So here we put minus f of x is equal to sin x plus cos x plus c. No, option B is again another method we have used. So the correct option is B. So first of all we write this integration 1 divided by e power x whole square minus 2 square we can write. So dx. Now we take the supposition. Let's suppose that let e power x is equal to t. So if we are differentiating with respect to x, so the result will be ex. Ex derivative is ex. So dx. Now here dx is available. We change this result, and here dt divided by ex and dx. Ex is, we know that ex is equal to t. So we get this result dx. Now we substitute the result dx as we get here dt divided by t, and this result we put the result here ex is t square minus 2 square under root. So this is the formula we get here dt t and t square minus here t square. So this is the formula of secant inverse formula. Here we are using secant inverse formula, secant inverse t divided by 2, and here 1 by a, 1 by 2, 1 by a plus c formula. Power 5x square plus 1 dx. What is the result? So if we take the supposition here, once again if we take here, let suppose that 5x square plus 1 is equal to t. So we are differentiating with respect to x, and one derivative is 0 dt. So we get 10x and dx plus one derivative constant 0 dt. So here x and dx is available, x and dx is available. So x dx is equal to dt divided by 10. Now we substitute this result in the place of this result. We put dt divided by 10, and in place of e power 5x square we put t. So we get the result 1 by 10 integration e power t dt. So 1 over 10. So as we know that integration of e power x is equal to ex, and here is et, and further derivative t is equal to 1. So plus c. 1 by t, and in the place of t we put the result 5x square plus 1 plus c. Now we check the result here. Option A is here. Option A is the correct answer. Number 124, integration cotangent under root x divided by under root x dx. Here we are using substitution method. First of all we take suppose that let x under root is equal to t. X under root we can write and has power 1 by 2. So differentiating with respect to x 1 by 2, x 1 by 2 minus 1, and further derivative of x dt. So 1 by 2 x we get minus 1 by 2 dx dt, and here we get 1 by 2 if we change into positive, so that will be x 1 by 2 dt, and we can write 1 by 2 dx. This will be equal to under root x dt. Here dt we are required dt x already available in the question, and 2 multiply to both sides. So this will be equal to 2 dt. In the place of integration here we put integration cotangent 3 and dx in the place of we put 2 dt. So 2 integration cotangent 3 dt, and as we know that we write cos t sin t dt. Of sin t plus c and 2 sin t we get put here sin t we already given under root x plus c. Now we check the answer. Option c is here the correct option. 2 last we sin x cos square x plus 1. If first of all we simplify this function, we can write sin x and cos x whole square we can write plus 1 square we can write also. So it means that here we take supposition here. Let's suppose that cos x is equal to t. So cos x is minus sin x dx is equal to dt. Here we are required dx is already here. This is dx. So sin x is available, dx is minus. We try to finish multiplying or dividing both sides by minus 1. So we get minus. Now replace the question here. We get minus dt in the place of this value. So we get here minus dt, and we get here t square plus 1 square. So we get the formula here minus dt 1 square plus t square. We can also write this is the formula of tangent inverse t plus c. So we put here minus tangent inverse in the place of t we put cos x plus c. Now we check the answer. Option c is here the correct option. Simplification t under root we can write 1 by 2 and t square dt. So bases are same, so we add the power 1 by 2 plus 2 dt. So integration 2 is LCM we can write 1 plus 4 dt, and d he can write t5 by 2 plus dt. Now using the power exponent rule, t5 by 2 plus 1 5 by 2 plus 1 plus c. So we get here t2 is the LCM, we get 7 by 2, and here 7 by 2 plus c. Now we can write 2 divided by 7 t7 by 2 plus c. 2 divided by 7 in the place of t we put here t. So there is we have not taken any supposition, so the answer is same. And here we change here 2 divided by 7 and 7 divided by 2 is C is the correct option. Thank you very much for watching. This is the last video of integration. All candidates are required. If you have any question or any queries, please comments me. I will try to solve it. Thanks once again for watching. Please subscribe my channel and share this video with your friends, colleagues and all other relatives. Thanks once again for watching.